As you know, computer vision models use many AI projects such as object detection, image segmentation, motion tracking, etc. Training these models is a challenging task. This task requires big labeled data and powerful computers. This is where Lightly comes into play. Lightly is a new framework developed by Lightly AI. If you don't know yet, Lightly AI is a platform that provides the best toolkit for implementing your generative AI projects. You can use the platform for data creation, model training, and edge deployment. Let's talk about what Lightly is. This framework helps you train immediately your computer vision models without requiring labeled data. You can use this framework for your computer vision projects like video analytics, robotics, medical imaging, vision inspection, agriculture. This framework also supports popular model trainings like TorchVision, YOLO, PyTorch image models, Ultra Analytics, etc. Cool, right? In this video, we cover how to train a model and fine-tune it step by step. First, let's install Lightly. To do this, let's go to the Colab. Okay, our Colab is ready. The first thing we're gonna do is set GPU. To do this, we're gonna click here and then press change runtime type. After that, let me select GPU. Press save. Awesome. To install Lightly, let's go ahead and type pip install. Let's write Lightly train. All we need to do is run this cell. Yeah, it started to install. The best feature of Lightly is that it uses a self-supervised learning technique. You may wonder what this technique is. This technique is a machine learning approach that allows AI models to learn from unlabeled data. It's done. The framework is ready to use. Let's take a look at the version of this framework. First, let me import Lightly. Import Lightly. Next, let's take a look at the version. Lightly.version. There you go. You can see the version here. Let's go ahead and take a look at how to train a model. What we're gonna do is prepare our data we'll use. You can use any image dataset for training. Note that you don't need labeled data to train the model. The dataset we're gonna use is Clothing Images dataset. We can install this dataset from GitHub. Let's explore this dataset here. The dataset includes several hundred images. Here are the dress images. You can take a look at these images. I'll link this dataset in the description below. To clone this dataset, all we need to do is the git clone command. Git clone. After that, we're gonna paste the dataset link here, like this. The last thing we're gonna do is specify the folder we'll clone. Let's say my data dir. Let's run this cell. Awesome, our dataset is ready. You can see this dataset in Colab files. Here are the images. If you click on an image, you can see it here. What we're gonna do now is remove that git file. Let's type rm-r my data dir /.git. Okay, let me run this cell. Cool, our dataset is ready to use. The first thing we show you is how to train a model with Lightly. To do this, we're gonna use a few codes. Let me show this. Let's call the train method lightly_train. Now, let's specify the output directory. Out equals, let's give out my experiment. This file will include training logs, model checkpoints, and outputs. Next, let's pass our data into the data argument. Data equals my data dir. After that, what we're gonna do is specify the model architecture. To do this, we're gonna leverage TorchVision. Let's write model equals, and then let's utilize the ResNet 18 architecture in TorchVision. TorchVision. Let's type ResNet 18. Okay, we set the model. Next, let's specify the epochs argument. This argument shows the number of training iterations. epochs equals, let's give 100. The last thing we're gonna set is the batch size argument. Batch size equals 128. Cool, our codes are ready to train. All you need to do is run this cell. Let's press here. As you can see, training started. You can check out the training here. Note that checkpoints are saved in the out folder. After finishing training, you can find the trained model in the exported models folder. Note that the model is in PT format. This is because we use TorchVision. Okay, our pre-trained model is ready, but this model cannot work for tasks such as classification, object detection, or segmentation. To address these problems, you need to fine-tune your model on a labeled dataset. To do this, we're gonna use PyTorch. Let me show this. The first thing we're gonna do is prepare the images to be input into ResNet. Let me pass the code snippet here. Okay, our transform variable is ready to use. This variable will resize images and then convert them to a tensor image. After that, set the data type. The next thing we're gonna do is load the dataset using our transform variable. Let me pass the code snippet here. Image folder automatically labels images based on folder names. Data loader allows you to load your dataset. Okay, our dataset is ready to pass the model. The next thing we're gonna do is load our pre-trained model. I'm gonna pass the code snippet here. Cool, our model is ready to use. Easy peasy, right? Our task is image classification, right? So we need to update the classification head with the correct number of classes. To do this, we're gonna use the linear class in the torch_nn module. Let me pass the code snippet here. Okay, the classification head is ready. The next thing we're gonna do is set the GPU and then move the model to the GPU. To do this, I'm gonna set the device variable. After that, use to the method. Awesome, we moved the model to the GPU. Next, we're gonna set the loss function and optimizer. To do this, we're gonna use the cross entropy loss function and the add optimizer. Cool, our functions are ready to go. The last thing we're gonna do is train the model. To do this, we're gonna use a for loop. I'm gonna set 10 epochs to show you how to train a model. All you need to do to train the model is run this cell. Awesome, the training has started. This loop fine-tunes our ResNet on our labeled image dataset. Remember, we use the self-supervised learning technique with Lightly-Train. Here, we're just using supervised learning with the labeled data to fine-tune our pre-train. Note that loss is calculated in each epoch. The output shows the loss decreasing over time. Yeah, it's done. Our fine-tuned model is ready to use. You can now use this model in image classification. Cool, right? In this video, we've seen Lightly-Train, a new framework for computer vision. You can use this framework to train computer vision on unlabeled data. By doing so, you can reduce model training time and cost. Yeah, that's it. I hope you enjoyed it. Thanks for watching. Don't forget to subscribe, like the video and comment. See you in the next video. Bye for now.